Hi, I'm Elizabeth with LogicWalk. Previously, we learned how to use commands like pwd, ls, and cat from the shell. In this lesson, we're going to look deeper at how the LWOS processes these commands internally. All three of these commands retrieve information from the file system, but they do not modify the file system or change the current working directory. For this lesson, we will use the following file system. Suppose the user types the pwd command into the shell. As soon as the user presses the Enter key, the LWOS receives a keyboard interrupt and begins processing the command. At this moment, nothing has been printed to the shell yet. Here is the state of the LWOS immediately after the Enter key is pressed. The host name is computer1, the status is idle, and the current folder index is 2. The keyboard interrupt is set to true, indicating that the OS has detected a keyboard input. In the shell section, the press key is Enter. The user input contains pwd, and the buffer contains the shell prompt, along with the command the user entered. In the file system section, the mode is set to read, the signal is false, and the data contains the folders and files currently loaded into memory. The LWOS loads the file system from disk at startup, and keeps the in-memory file system synchronized with the hard drive. Because the file system is already stored in memory, the LWOS does not need to read from the hard drive in order to process the pwd command. Instead, the OS uses the current folder index to determine the current working directory. Next, the LWOS processes the user input. Whenever the user presses the Enter key, the OS follows the same general process to prepare the command for execution. First, the OS adds a new line to the shell's buffer. Next, it processes the command entered by the user and stores pwd in the command property. Command arguments are stored in the token stack, but pwd doesn't require any arguments. Finally, the LWOS resets the shell's user input to an empty string. At this point, the OS has processed the command and prepared it for execution. The LWOS then sets the keyboard interrupt to false, indicating that the keyboard event has already been processed. Now the OS is ready to execute the command. The LWOS uses the current folder index to retrieve folder 2 from the file system data, which represents the current working directory. The OS appends the path of folder 2 to the shell's buffer. It then appends a new shell prompt to indicate that the command execution is complete and the OS is ready for more input. Here's the final OS state after the pwd command completes. Everything else remains the same except the command property, which is now set to null, indicating that command execution is complete. Now let's return to the shell. After the user typed pwd and pressed Enter, the shell displays the contents of its buffer. Now let's look at the ls command. The ls command prints the contents of a folder. Suppose the user types ls photos into the shell. This command tells the LWOS to print the contents of the photos folder. For this example, the current folder index is set to 0, so the current working directory is the root folder. As before, when the user presses Enter, the LWOS processes the command and prepares it for execution. Here is the updated LWOS state after the command has been parsed. The status is idle, and the current folder index is 0. The command property is now set to ls. The remaining token is photos. The keyboard interrupt is set to false, indicating that the keyboard event has already been processed. The shell's user input is empty because the OS has already processed the command input, and the buffer contains everything that was typed into the shell. Now the LWOS is ready to execute the command. The argument photos is a relative path, so the OS looks for it inside the current working directory. Since the current folder index is 0, the OS retrieves folder 0, the root folder, from the file system data. The LWOS then looks for photos inside the root folder. Since photos is a folder, the OS retrieves folder 1. Folder 1 has this path. Inside the folder, there is one file, info.txt, and one folder, 2021. The OS appends the file and folder names to the shell's buffer. It then appends a new shell prompt to indicate that the command execution is complete and the OS is ready for more input. Here is the final LWOS state after the ls command completes. Everything else remains the same except the token stack, which is now empty, and the command property, which is now set to null, indicating that the command execution is complete. Now let's return to the shell. After the user typed ls photos and pressed Enter, the shell displays the contents of its buffer. Now let's look at the cat command. The cat command prints the contents of a file. Suppose the user types cat name.txt into the shell. This command tells the OS to print the contents of the name text file. For this example, the current folder index is set to 0. Here is the updated OS state after the command has been parsed. The host name is computer1, the status is idle, and the current folder index is 0. The keyboard interrupt is set to false. The command property is now set to cat. The remaining token is name.txt, and the shell's user input is empty. Now the OS is ready to execute the command. The OS looks for name.txt in the current working directory, retrieves the value James Madison, appends it to the shell's buffer, and then appends a new shell prompt. Here's the final OS state after the cat command completes. Everything remains the same except the token stack, which is now empty, and the command property is now set to null, which is indicating that the command execution is complete. Now let's return to the shell. After the user typed cat name.txt and press enter, the shell displays the contents of its buffer. And that wraps up this lesson. In the next lesson, we'll look at the cd command and examine how the OS updates the current folder index as users navigate through the system.